So, of course, today is the first day of November. So we've been talking about evidence of evolution. We said the first piece of evidence, the first sort of general category of evidence, is the fossil record. So hence, watching a movie, whoops, flippy, about whale evolution. And I loved how, and I'm going to screw up his name, Hans Thewissen, because it's Dutch, so anyway, the guy who teaches at Neocom, right there in Rootstown, was saying whales are often now used as a textbook example of the fossil record showing evolution because they managed to fill in all the pieces. You know, we can see step 1, step 2, step 3, step 4, step 5, step 6. We can see all those species. Do you think we always get all the pieces? No. So, here's the thing. Some things make better fossils than others. Fossils are really good at showing hard-bodied organisms, those that have skeletons, and woody plants. And I forgot to bring my tree fern fossil again. Dagnabbit. There are some things that make great fossils. Things that have skeletons make fantastic fossils. We can find mineralized bones. We can find mineralized bones. That is something that they often show. We can find shells. If you ever get a chance, has anybody ever visited Cincinnati, Ohio? Okay. Nice town. Nice place to visit. If you go to Cincinnati, you should go to Cedar Creek State Park, nearby Cincinnati. It's a state park. Doesn't look all that impressive. You can go have a picnic. You can go for a walk. You can go swim in the lake. Or you can pick up a random rock, and the rock layer that's exposed there is so full of fossils that pretty much every rock you pick up is completely packed with fossils. It's really cool. Including trilobites. I didn't find any trilobites. Mrs. Haylett and I went there in the snow and tried to dig fossils. But it's a big thing. You go to Cedar Creek and dig fossils. Anyway, fossils are good at showing those kinds of organisms. Fossils are also pretty good at showing the geologic time of death. How many of you have ever watched a crime show? Okay. How do they figure out time of death on a crime show? Do you know? Do you know? How? Science stuff? You got a more specific answer than that? By temperature. They usually stick a giant, looks like a giant meat thermometer, boonk, into the corpse's gut. Because they know the rate at which a body cools, given the ambient temperature. And so by taking the temperature of like the liver, they can figure out how long the corpse has been cooling, how long it's not been maintaining homeostasis anymore, because it doesn't need to, because it's dead. So fossils show a time of death, but not the same way. Were they able to pinpoint when Pakicetus disappeared from the fossil record? Yes. I don't remember it off the top of my head. One of them disappears 49 million years before present, but I don't remember which one. They can see when those fossils stop appearing in the fossil record. And that tells you, oh, this species is gone. This species has gone extinct. So that's what fossils are really good at showing. Now, what fossils stink at showing are soft-bodied organisms. Not very good at that. So, you know, you're not going to find an earthworm fossil. Bacterial fossils are tough. There are some, but they're not fossils of the actual bacteria. They're fossils of the mats, which the bacteria show. You're very often not going to see fossils that come from grasslands. You're not going to see fossils that come from deserts. You might find a mummy of something that died in a desert. You're probably not going to find a fossil in the sense we're thinking of it. Because if you remember, fossils usually form when we bury stuff in basically mud or silt or swampy areas. That's how we get good fossils. So when something dies someplace dry, it doesn't necessarily happen. In desert regions, you can get what's called, It's called spontaneous mummification. You know what a mummy is, right?
Yes.
Good. When we go to the Carnegie, hopefully late November, early December, you'll have a chance to see several mummies on the 3rd floor. But you can have, those are mummies that were carefully prepared. People made a real effort to make sure that those things were preserved. In spontaneous mummification, if you die under the right conditions, sometimes you get sort of accidentally mummified. Cool! It happens. Question. Okay, so not everything gets shown in fossil records, which means we don't always get that neat progression that we had with the whales. We don't always get step 1, step 2, step 3, step 4. There are often missing pieces. And actually, if you look at whales, in 1970-something, 78, 79, Gingrich discovers Pakicetus. They don't know about Ambulocetus until 94. That's a pretty long gap. So we don't always have a complete fossil record, but it's still a good source of evidence. Okay, so let's go back to this idea, this geologic time of death. We said on CSI they stick a thermometer in the dead body's liver. Ew. How do you figure out the age of a fossil? How do they know Pakicetus shows up 70 million years ago or whatever it was? Test it for something. Okay, well that's a good start. I like that start. They test it for something. Who wants to add to that at your table? Talk about it. How do you think they figure out geologic time of death? Very commonly, they look at the rock layer that the bones were found in. And if you can figure out the age of the rocks that those bones were found in, then you can figure out approximately how long ago the thing died. Now, this does not give you like Tuesday at 2:30. This gives you 49 million years ago. You know, give or take 100,000 years. This is not that kind of super exact. This idea of law of superposition. I would like you all, when you're done typing, to play a little game at your desk, at your island nations here. This is a game that I often play with my daughter. Let's see, Riley, you want to be my guinea pig? You can be my demo person. In general, go ahead. One hand down for everybody. Hey, you're not letting hand. Okay, stop.
No.
So, just like you stacking your hands on top of one another, when rock layers form, and I'm going to shrink this all for a second. When rock layers form, in general, what we see is that we get a layer of rock of some sort that forms. Then we get another layer over it. Then we get another layer over that. Then we get another layer over that. You see where this is going?
No, I don't.
Where's the youngest rock layer?
Top.
Top.
You said youngest. You tricked us.
That's not tricky. The youngest rock is at the top. The oldest rock is on the bottom. Now, there are other things that can happen. Hey! Zip. There are other things that can happen that can flip stuff around and fold stuff and break stuff. That's a whole separate class in and of itself. If you go on to take a geology class in college, you will spend lots of time taking maps of rock layers and matching them and figuring out which is youngest and which is oldest and what thing happened first. It's a big puzzle. So this is not 100% this easy all the time. But in general, we can age rock layers. We know what's older than what, and we can actually get those year dates because of something called radioactive decay. We're not going to go into that here. You may have had a little bit of it in physical science. You might not have. But basically, the atoms inside a rock change over time, and we know the rate at which they change. So we can use a machine that we put stuff in to test the atoms that are contained in a rock layer. And that's what gets us the actual years. So this just gets us a relative age. This is like looking at an infant and a toddler and a preschooler and saying, well, that one's the youngest, that one's the middle, and that one's the oldest. It doesn't tell us that the infant's 8 months old. It doesn't tell us that the toddler's 2 years old. It doesn't tell us that the preschool kid is 4. We have to do something more for that. So we can get relative age just by looking at what's on top, what's on bottom. To get more specific age, we have to actually do testing with a machine that we put it in, that we look at the atoms inside the rock. We can also look at the bones with that same machine. So everybody, take a deep breath. What you breathing in? You're breathing in a whole mix of stuff. Air, which is nitrogen and oxygen and carbon dioxide. Has anybody here consumed any food today?
No.
No? Okay, well, hopefully you'll consume some food at lunch. Oh, yes, don't even get me started on the candy. You consumed some food. You know what that food was made of?
Food.
Atoms. Atoms. Lots of them are carbon atoms. You're a carbon-based life form. You're taking the carbon from the, Snickers bar. What did I steal from my daughter last night? 3 Musketeers. From whatever candy you're eating, huh?
You only took 3?
You're taking those carbon atoms from whatever you ate, and you're using them to build your body. Your body's breaking down the molecules in the candy bar or in the apple or in the piece of bacon or in the whatever you ate, the pizza you had for breakfast, breaking it down, building your body with it. Now, here's the weird part. There are actually a couple different kinds of carbon atoms, and one of them is radioactive. Did you know that? Did you know that you're radioactive? Because you all, right now, right here, are enough to set off a Geiger counter. Tick, 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 tick. It's a machine that measures radioactivity. You're radioactive. And every living thing on the planet is slightly radioactive. It's okay. It's fine. It's cool. It's cool. Don't panic. Don't panic. Because you are taking in those little radioactive carbon atoms, when do you stop taking in food? When do you stop eating permanently?
Yes.
When you die.
When you take a dirt bath.
So, at the point when an organism dies, they stop taking in those radioactive atoms. And then those radioactive atoms start changing. We can look at how many of them have changed to figure out how long ago a dead thing died. Yes. So we can look at dinosaur bones. Well, they're outside the range. We can look at bones from an organism that died 50,000 years ago. And we can peg it down to that 50,000 years. Pakicetus is too old. We have to rely on other kinds of aging for that. I think 60,000 years is the limit for radiocarbon dating. So things that died in the last 60,000 years you can peg with the carbon. Everything else you have to use other atoms. But what's number 1? Fossil record. That's the first strand of evidence. Now, there are more than 3 strands of evidence. There are thousands of strands of evidence for evolution, but these are the 3 big ones that we're going to talk about. The second strand of evidence is structural. Hey, does that look like any picture that you've drawn recently?
Yeah. Yes.
It does! Why did I have you draw that? So it would be stored in your brain. Yes, phalanges. Everybody hold up your phalanges and wiggle them. I know, you didn't draw a cat one. But we can look at any mammal. No, these are your phalanges. Just wiggle your phalanges. Yep, phalanges. You got phalanges here, you got phalanges here. You got 20 phalanges, yeah. Okay. Structural evidence. What does structure mean? What's a structure? Support. Formation of something.
You're depressed, but you don't.
Structural. It's how something's built. A structure is how something is built. Structural evidence relates to how organisms are built. You are built from bone and muscle and skin. Homologous structures. What does homo mean? Prefix homo. Same. Same. Homologous structures have the same underlying structure. Homologous structures have the same underlying structure. So they appear in different species, but they have similar underlying structure. They share shape attributes. Okay? So you looked at the bones of the forearm in mammal species. You, a cat, a bat, a whale. I think they show a penguin in your book. Huh? You could look at an orangutan's hands, yes. Oh, do they show Oh, which isn't even a mammal species. It's a reptile species. But it's a tetrapod. How many does tetra mean? 4. Tetra is 4. Think about Tetris. There are 4 ways to put down each block. Yes, you just made that connection. Yeah. Tetra means 4. What's a pod? Everybody stomp your pods. Yeah. Okay, that's enough pod stomping. Oh, don't kick anybody. You are a tetrapod. How are you at 4 feet? Where are the other 4? You don't walk on them, but you got them. So tetrapods are things that have a 4-limb body plan. I can't do all 4 at once. I'd fall down. We are bipedal. We walk on 2. But we have 4 limbs. We are a 4-limb body plan. So if you look at all of these tetrapods, that's weird. You find the same arrangement of bones. 1 bone, 2 bones, all these little tiny bones, these phalanges. 1 bone, 2 bone, all these little tiny bones, phalanges. 1 bone, 2 bone, all these little tiny bones, phalanges. 1 bone, 2 bones, all these little tiny bones, phalanges. That's bizarre. Huh? No, I do not. Writing this all down? The fact that all of these organisms share these structures is evidence of common ancestry. What did we say evolution was? A couple things. It's the idea that we have common ancestry for lots of organisms over a long period of time. It's also, of course, shifts in gene frequency. These homologous structures provide evidence of what's called divergent evolution. So divergent evolution is where we have one organism that has ancestors. Well, that's, I don't know what that is. There we go. And those ancestors diverge from one another. They begin to look different as you go generations and generations and generations out. Now, the deltoid muscle here. The deltoid muscle here. The deltoid muscle here. Same basic muscle. I know someone who was studying to be a vet tech, and his mom is a nurse. And at some earlier point, I had tutored, it's a cousin of mine, I had tutored him, and I said, well, if you need help with anything, let me know. And his mom said, oh, no, parts is parts. I got this. Because I helped him with some algebra and some physical science. She's a nurse. She knows her muscle groups. They're the same on a human as they are on a cat, as they are on a dog, as they are on a horse. Same basic muscle groups. Same basic arrangement of muscles. You're going to find... Here's the thing. Not all of these homologous structures do the same thing. Think about the whale. Does the whale have back legs? Yeah. They have a lot of remnant bones. They have a remnant pelvis. Does that pelvis serve a function in a whale? No, it's not even attached to anything. It's just floating back there. In modern whales, there are really little tiny bones that aren't really serving a function. They're very reduced in structure. We're going to see a picture of them in a little bit. But they provide evidence of this divergent evolution. Okay, what's the second major strand of evidence? Structural evidence. And within structural evidence, there are sort of two subcategories. Category A is what? What did we just talk about? Same shape. Same homologous. Yeah, homologous. Homologous. If that's the way you need to remember it, go for it. Okay. There's another subset of structural evidence. Who here has had their wisdom teeth pulled? Has anybody had their wisdom teeth pulled? You have, okay. Was it a whole lot of fun? I hear it's just fantastic. It's delightful. People recommend it as like a recreational experience. You should do it on summer vacation. I'm joking. If you don't recognize sarcasm, you're lost. Wisdom teeth. Why do you have wisdom teeth? Because your mouth used to be bigger. Not your personal mouth, but us as a species. Somebody asked on their I love getting the little what other questions do you have, because it's things that I can use in class. And one of them was, have humans evolved in the last, I think it was 500 or 1,500 years? Wisdom teeth. Really? Wisdom teeth. Interesting. Why on earth am I asking about wisdom teeth?
Because it's science.
Well, it is science. Do you really need your wisdom teeth?
No!
No, why can Paige exist perfectly happily without them? Samantha's going to exist perfectly happily without them. Lots of people get them pulled. Did they hurt? I'm not asking you, I'm asking Paige. She had them pulled. Before you had them pulled, did they hurt? Were they painful? Okay. Did they get infected by any chance? This is the kind of thing only biologists... Oh, did they get infected? Did they? Sicko. Okay. All right. The other... Hey, let's rein it back in. The other piece of structural evidence is what are called vestigial structures. Everybody say it with me, all together. Vestigial. Vest, like a vest that you wear. Vestigial structures. So vestigial structures are things that don't serve a purpose anymore. At some point, they did. At some point, they were important. How do we know they were important? Because they were worth the energy to grow them. What did we say about the three-legged man? What does it take to grow any part of your body? Energy. Every single little cell that your body grew required energy to grow it. And then if it does not offer some kind of advantage, eventually it kind of disappears in general. Wisdom teeth. Wisdom teeth. Did it take your body energy to grow those teeth? Yeah. Absolutely. They grew in your jaw, either when you were a fetus or when you were very young. I'd have to look that up. I think those develop later and then come in later. I'd have to look it up. Vestigial structures are considered evidence of an organism's evolutionary past. What would have been different about humans' past that we would have had different teeth?
We didn't have knives to cut dinosaur meat up.
Different diet, different methods of eating. So both the fact that we didn't, you're right, we didn't cut food up the way we do now, and also our diet was different, and we needed more grinding teeth. We don't need that so much anymore. Well, we used to eat raw meat. We used to eat a lot of things raw, as do most organisms on the planet. And we probably ate a lot more fibrous foods than we do today. And those things require grinding. Do you need your wisdom teeth?
Not anymore.
Not really, not so much. Now here's the question. Are they any disadvantage? I mean, how many calories do you think it really took to grow wisdom teeth?
10, 22.
Not many. Not many. They're cheap in that regard, right? Is there any way that your wisdom teeth could kill you?
Yes.
How?
They get infected.
They get infected. Now, what do you do if you get an infection? Take an antibiotic! What would you do 1,000 years ago if you got an infection? Die! And what if you get an infection up in your head, really close to this thing, your brain? You die. People used to die of infected teeth all the time. Pretty common prior to the era of modern antibiotics. Now, not to freak you out, but you know that seems to be what I specialize in. What happens if all antibiotics go away?
Death.
We go back to a world in which a lot of people die from things like infected teeth.
Death.
Yeah. Death and lots of it. So, can having extra teeth that there aren't really room for in your jaw kill you? It could. Now, you know, as long as we're living in a world where we have antibiotics and we have the availability of antibiotics, we have antibiotics that allow you to go have those surgically extracted. Were you on an antibiotic after they pulled them? Yeah. Why? Because when you have surgery, there's a risk of infection. Can your wisdom teeth kill you? Well, yeah, they can. Fortunately, right now we're living in a world where it's not so likely they will. So is there an evolutionary advantage to getting rid of wisdom teeth? Not so much for us right now, because we can have them surgically extracted before they get infected. We can have an antibiotic when they're surgically extracted. But in a world before antibiotics, was there an evolutionary advantage to getting rid of wisdom teeth for humans? Yeah. Did any of you, can you consciously will your wisdom teeth to not develop? No. If you think really, really hard, push them back down into your jaw? No. If that worked, Paige wouldn't have had surgery. Guaranteed. So those of us who have an odd number of wisdom teeth, do you know what we are?
Different.
Mutants!
Not so much.
Oh, yes, totally. Totally a mutant. I'm in the odd number of wisdom teeth mutant club. Tori's in the odd number of wisdom teeth. Are you in the... Okay. Okay. Alexis is in the odd number of wisdom teeth mutant club. Don't worry, I'm going to call you all mutants before the year is out. Why do you have 4?
I thought everybody had 4.
No. No. Go ask your dentist. I don't have 4. And you have 6? You have extras?
I have 8.
I went to school with a woman who had a full extra set of teeth. She had a second set of teeth that came down from the roof of her mouth. She had them all surgically removed when she was in high school. It was horrible.
My dad had 7 wisdom teeth, so...
Really?
Yeah.
It's possible. Mutants! Bunch of mutants! Stuff happens! Stuff happens. Yeah, this woman I went to school with literally had extra... I don't know if it was every single tooth, but she had a lot of extra teeth that came in behind her adult teeth. So it was like almost a full extra set. And she had a little bit of a speech impediment because of it, because it's hard to talk. You know, just like little kids who have lost teeth have a lisp, it's also hard to talk with extra stuff in your mouth. And so she had a little bit of a speech impediment, and they were surgically removed, and she had braces, and she had corrective surgery. I don't imagine it was fun, but it happens. Here's something to remember, and I will say this more than once to you before this year is out. Normal is whatever's normal for you. So for Julie, the woman I went to school with, having almost 2 full sets of teeth was normal. Now, is that common? No. Is that usual? No. Is that average? No. You know, thinking about those distribution curves that we looked at. If you're 7'2" and you're way up on that top end of the distribution, is 7'2" normal for you? Yeah. You wake up every morning, you're 7'2". Go to bed at night, you're 7'2". Is that usual? No. Is that common? No. It's at one end of a distribution. So could we do a distribution for the number of wisdom teeth that humans have? Yes, we could. Oh, yes, we could. Because, you know, I love to graph things. It makes me happy. So, what do you think is the mode for human wisdom teeth? I'm going to guess that, I mean, 4 is what you thought till 10 minutes ago. You didn't know people could have a different number. So maybe there's 4 here. Maybe there are people with 8 wisdom teeth. Maybe there are people with 0 wisdom teeth. Do you really have 8? Okay. It's possible. It's quite possible. If that distribution shifts, what do we call that? What do we call it when we have the shifting of a trait in a population over generations? Evolution. So are humans evolving out of having 4 wisdom teeth? Maybe. If there's an evolutionary advantage, it can happen. Wisdom teeth are considered a vestigial organ in humans. Okay, let's look at a couple other vestigial organs. And then I'm going to give you a recall quiz while it's all fresh. I think it's, I don't know if it's boas or pythons. Who here has snakes at home? Anybody have pet snakes? I usually have 1 or 2 people who have a boa or a python. Oh, don't get them. They're really not good pets. They're very cool, but you know what? Get a native snake. Get a native snake from a reputable breeder. Corn snakes are awesome. Well, boas and pythons don't kill you when they bite you. They kill you by squeezing you to death and then consuming you. Okay, so snakes don't have legs, do they?
No.
Yeah, some of them do. Snakes have legs? So, look up there. This is, and I'm going to get this wrong, I'm sure. There are some snake species in which, if you look closely, there are what are called spurs on the outside of their body. They look just like little tiny pointy things. If you look at the skeletal structure that underlies them, guess what you find? They're actually little legs. Like a little tetrapod arrangement of bones. That's a vestigial structure. Now, do these serve a function? Not the kind of function that they would have served at one point. They don't walk on them. They don't move with them. They slither. Now, in some species, these vestigial structures are used for something else. No. But in this case, they're not. No. No, snakes. No, absolutely not. I don't know. They're really tiny. They are really reduced. We'll look up some pictures of them. They're vestigial. They're a remnant of some earlier form. So if we look at whales, here's an example of an image. Here's a question that maybe I'll put up as a research question, because I would like to know more about this, and frankly, I don't have the time in my life to read up on it. What do we know about the evolutionary fossil record of snake ancestors? I would love to know that, because that would give us the evidence of where did those structural changes occur. You know something about this. If we go back to here, one piece of the structural evidence is homologous structures, which means they have the what? Same shape. Yeah. The other piece of structural evidence is what? Vestigial structures. Vestigial structures. Here's something that's... How many of you have heard that the appendix is useless? Okay. Has anybody here had their appendix out? Oh my goodness, 2-banger. All right. I know a woman I actually personally know a woman who was born with no appendix. Alice Madej had abdominal surgery at a military hospital in the 70s, and in the 70s in a military hospital, they would say, if you had never had abdominal surgery, hey, while we're in there, we're just going to take the appendix just in case. So they said to Alice Madej, have you ever had abdominal surgery? And she said, nope. Now, I don't know why they couldn't just look and see that there was no scar on her abdomen, because abdominal surgical scars in the 70s were huge, and they couldn't do little laparoscopic things. They went in, they did surgery. After surgery, the surgeon comes to Alice Madej and says, you lied. No, it didn't. Just regained consciousness here. Why are you yelling at me? She didn't have an appendix. What is Alice Madey?
Mutant.
A mutant! She's an appendixless mutant. Can it happen? Sure. It can happen. So, the appendix was always referenced as being a vestigial structure, and it may be. At one point in human evolutionary history, we probably had a much longer gut, and the appendix is just this sort of little blind pouch that hangs off one side of your guts on the inside. Food doesn't normally process through it. Stuff can get stuck in it, though, and get infected, and then it goes to appendicitis. I had a student a couple years ago who actually had an appendicitis. And I don't remember if it burst. He had emergency appendix surgery, which is not a good thing to have. Oh, yours was emergency surgery?
Yeah, I was rushed into surgery that day.
Oh, goodness, you've hit all the boxes. Okay. We were always taught that the appendix was a vestigial organ. That's what I learned as a kid. There's no need for the appendix, it's vestigial. That may be, but they've actually found that there's an evolutionary advantage to having your appendix. It does serve a function. Now, it may not have been the original function of that little chunk. When you take an antibiotic, we talked about this. Which bacteria in your gut do they kill? All of them. Yeah, the ones in your gut, but it doesn't differentiate. It doesn't kill just the bad bacteria and leave the good bacteria, which is why sometimes people get nasty bouts of diarrhea after an antibiotic. The appendix serves as like a little safe room for some of your gut bacteria. So if you have an appendix, sorry guys, if you have an appendix, it's sort of a hiding place for the good bacteria, and after a round of antibiotics, people who still have the appendix intact this is what I've seen, tend to recover their gut bacteria faster because they can repopulate from that little sort of hiding place. Now that said, that's not an advantage if it tries to kill you. If your appendix tries to kill you, it doesn't do you any good to have it. It should be gone. But okay. We've talked about 2 of the major strands of evidence. We're going to do a quick... Oh, no, we're not. We're going to do a recall quiz when you walk in tomorrow. So when you walk in tomorrow, you should be prepared to look over your notes from today, take a quick recall quiz. Yeah? Yeah.